According to the National Electrical Code, specifically Article 450.13a, a disconnecting means is required at a transformer if it's installed in a separate room or enclosure from the primary overcurrent protection. The code states that where transformers are installed in a separate room or enclosure, there shall be a disconnecting means located adjacent to the transformers, readily accessible and operable from outside the room or enclosure. This requirement addresses several crucial aspects of electrical safety and operational integrity. Firstly, the disconnecting means is essential to protect personnel. In the event of a fault or during maintenance, the ability to quickly and safely de-energize the transformer is paramount. Without a readily accessible disconnect, personnel could be exposed to hazardous voltages and currents, increasing the risk of electrical shock or arc flash. Secondly, it allows for safe servicing of the transformer by disconnecting it from the power source. Transformers, like all electrical equipment, require periodic maintenance and occasional repairs. A dedicated disconnecting means simplifies this process by providing a clear and reliable method to isolate the transformer from the electrical supply. This ensures that maintenance personnel can work on the transformer without the risk of accidental energization, thereby promoting a safer working environment. Thirdly, it prevents backfeed. Backfeed refers to the situation where power flows in the reverse direction through a transformer, from the secondary side to the primary side. This can occur if there is a fault in the system or if the secondary side is energized from an alternate source. Backfeed can create hazardous conditions by energizing circuits that are normally de-energized, potentially endangering personnel and damaging equipment. A disconnecting means that the transformer can prevent backfeed by providing a positive break in the circuit, ensuring that power cannot flow back into the primary circuit. Fourthly, it limits damage. In the event of a fault or overload, a transformer can be subjected to excessive currents and voltages, which can cause significant damage. The disconnecting means allows for the transformer to be isolated from the power system in case of a fault or overload. Promptly disconnecting the transformer can minimize the extent of the damage, potentially saving the cost of replacing the entire unit. This is especially important in critical applications where downtime can be costly and disruptive. The disconnecting means must meet certain requirements to be effective. Firstly, it must be suitable for the transformer's rating. The disconnecting means must be capable of safely interrupting the full load current and the available fault current at the transformer's location. This typically involves selecting a disconnect switch or circuit breaker with an appropriate amperage rating and interrupting capacity. The interrupting capacity, also known as the short circuit current rating, must be sufficient to withstand the maximum fault current that could flow through the circuit under fault conditions. Secondly, it must be readily accessible for operation. The disconnecting means must be located in a place where it can be easily reached and operated, even in an emergency. This typically means mounting the disconnect switch or circuit breaker at a convenient height and ensuring that it is not obstructed by equipment or other obstacles. In addition, the disconnecting means should be clearly labeled to identify its purpose. Thirdly, it must be capable of opening and closing the transformer circuit under load conditions. A disconnecting means should be designed to safely interrupt the flow of current when the transformer is operating under normal load. This typically involves selecting a disconnect switch or circuit breaker that is specifically rated for switching duty. Switching duty refers to the ability of the device to safely interrupt current when the circuit is energized. The requirements outlined in NEC Article 450.13 are designed to ensure the safety and reliability of electrical systems that incorporate transformers. By providing a readily accessible disconnecting means of the transformer, the code helps to protect personnel, facilitate safe servicing, prevent backfeed, and limit damage in the event of a fault or overload. These requirements apply to transformers installed in separate rooms or enclosures, where the distance between the transformer and the primary overcurrent protection device may be significant. In these situations, a local disconnecting means is essential to ensure that the transformer can be quickly and safely energized when necessary. It is crucial to understand and comply with these requirements to maintain a safe and code-compliant electrical installation. When selecting a disconnecting means for a transformer, it is essential to consider several factors to ensure that the chosen device is suitable for the application. These factors include the transformer's voltage and current rating, the available fault current at the transformer's location, the ambient temperature, and the environmental conditions. The disconnecting means must be rated to safely interrupt the full load current and the available fault current at the transformer's location. This typically involves selecting a disconnect switch or circuit breaker with an appropriate amperage rating and interrupting capacity. The interrupting capacity, also known as the short circuit current rating, must be sufficient to withstand the maximum fault current that could flow through the circuit under fault conditions. The ambient temperature can affect the performance of the disconnecting means. High ambient temperatures can reduce the current carrying capacity of the device, while low ambient temperatures can affect its operating characteristics. It is important to select a disconnecting means that is rated for the expected ambient temperature range. The environmental conditions can also affect the performance of the disconnecting means. In corrosive environments, it is important to select a device that is constructed of corrosion-resistant materials. In wet or damp environments, it is important to select a device that is rated for wet locations. In addition to these factors, it is also important to consider the ease of installation and maintenance of the disconnecting means. The device should be easy to install and maintain, and it should be readily accessible for inspection and testing. Regular inspection and testing of the disconnecting means are essential to ensure that it is functioning properly. The disconnecting means should be inspected periodically for signs of damage or wear, and it should be tested to verify that it can safely interrupt the flow of current. If any problems are detected, the disconnecting means should be repaired or replaced immediately. Properly installed and maintained disconnecting means can help to prevent electrical accidents and ensure the safe and reliable operation of electrical systems that incorporate transformers. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations. It is updated every 3 years to reflect the latest advances in technology and safety practices. The NEC is widely adopted by state and local jurisdictions in the United States, and it serves as the basis for electrical codes in many other countries. Compliance with the NEC is essential to ensure the safety of electrical installations and to protect people and property from electrical hazards. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for transformers, including the disconnecting means requirements outlined in Article 450.13a. The NEC is a complex and detailed document, and it is important to consult with a qualified electrical contractor or engineer to ensure that electrical installations comply with all applicable requirements. Failure to comply with the NEC can result in fines, penalties, and even legal action. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to check with the local authorities to determine what requirements are in effect. Compliance with all applicable codes and regulations is essential to ensure the safety and legality of electrical installations. The disconnecting means requirements for transformers are just one example of the many safety measures that are included in the NEC and other electrical codes. These requirements are designed to protect people and property from electrical hazards, and they should be taken seriously. By following these requirements, electrical contractors and engineers can help to ensure the safety and reliability of electrical systems. When working with electricity, it is always important to exercise caution and to follow all safety procedures. Electricity can be dangerous, and even a small mistake can have serious consequences. Always to energize circuits before working on them, and always use appropriate personal protective equipment. If you are not qualified to work with electricity, do not attempt to do so. Hire a qualified electrical contractor to perform the work. By following these safety precautions, you can help to prevent electrical accidents and injuries. In summary, the NEC requires a disconnecting means at transformers installed in separate rooms or enclosures. This requirement is designed to protect personnel, facilitate safe servicing, prevent backfeed, and limit damage. The disconnecting means must be suitable for the transformer's rating, readily accessible for operation, and capable of opening and closing the transformer circuit under load conditions. Compliance with these requirements is essential to ensure the safety and reliability of electrical systems that incorporate transformers. Always consult with a qualified electrical contractor or engineer to ensure that electrical installations comply with all applicable codes and regulations. When working with electricity, always exercise caution and follow all safety procedures.